Here in this problem we say that the big f of x is a primitive function of the function which is inside the integral, that is, f of x is the primitive function of e to the power of minus t squared. Let's write down the expression for f of x. We know that this theorem holds if we differentiate by x this primitive function f of x, which is given as an integral from 0 to x of some f of t dt, where x is the parameter and 0 is a fixed constant, which can be any constant whatsoever. We can even write it down and mark it as a. We know that this derivative is equal to little f of x. This will help us find the derivative of big F at point where x is equal to 1. So we need to know d of dx of f of 1, which is actually equal to f of x, small f of x, for x is equal to 1. That is, it's equal to e to the power of minus x squared, and we need to substitute x is equal to 1. So we have e to the power of minus 1, that is 1 over e. Now we need to find the second derivative. Of f of 1. And we will use the first derivative that we've already found. And we'll plug in x is equal to 1 after we get the expression. So we differentiate e to minus to the power of minus x squared, and we plug in x is equal to 1. So we obtain minus 2x times e to the minus x squared power for x is equal to 1, and that is equal to minus 2 over e. And now we are finished with part A. In part B, we have a different expression, and we have to express it in terms of values of f of x. So we have an integral of e to the power of minus u squared over 4 du, where u goes from 1 to 2. But the expression that we need is actually the expression where the subintegral function is e to the power of minus t squared. So our minus t squared has to be equal to minus u squared over 4. This can be achieved by a substitution where t is equal to u over 2. Therefore, we obtain that du is equal to 2 times dt. So now we have to be careful with our boundaries. U was equal to 1, t is now equal to 1/2 for the lower bound, and for the upper bound t becomes 1. We have e to the power of minus t squared, but we also have this factor of 2. And now we're almost there. However, in this case, we don't have 0 as a lower bound. F of x is the integral between 0 and x of this function. And we need to reduce our integral to the integrals where 0 is the lower bound. So we can easily see, after extracting tau, that this integral can be obtained by subtracting two integrals. One integral is integral e minus t squared dt, where t goes from 0 to 1, and another one is the integral where t goes from 0 to 1/2 of e to the power of minus t squared dt. So this is 2 times big F of 1 minus big F of 1/2. Using the definition of big F as an integral from 0 to x of e to the power of minus t squared dt.